Hello, we are students from Puiching Middle School. Today we will introduce our research, preparation, and experimentation of heavy metal biosorbents. Our introduction is composed of 5 parts: background, novel features, experimental process, data analysis, and future outlook. First, I will introduce the background of our research. We all know that water is very important to life. Organisms need water to survive. However, different bodies of water on Earth are now polluted by heavy metal ions. Heavy metal ions are toxic and causes adverse effects once ingested by the human body. Existing heavy metal absorbents such as chelating resins are very expensive and not biodegradable. Therefore, this study was conducted to investigate the absorption of heavy metal ions by biodegradable and low-cost substances. There are 3 main novel features of our research. Firstly, turning waste into treasure to protect the environment. As I mentioned just now, although there are existing industrial countermeasures to prevent heavy metal water pollution, it will improve the resource allocation and reduce the cost to a greater extent if we can use common materials to remove heavy metal ions. Secondly, the experimental steps are simple and low risk. Today's common methods of heavy metal ion removal are relatively dangerous and complex, and mainly done in a laboratory or industrial environment. If the research method is simple, we can easily achieve the effects of social implementation. Thirdly, this research is sustainable and can protect water resources. The most effective existing heavy metal ion adsorbent is artificial chelated resin. Its cost is high and it cannot be degraded easily. The absorbents used in this study are organic and non-toxic substances. Our study can have the most cost-effective way to clean up more water resources for the benefit of people around the world.
Now I will explain the experimental part. Experiment 1 is about the adsorption of heavy metal ions from water by 3 substances. The tested absorbents were chitin membrane, calcium alginate bits, and eggshell membrane powder. The solution tested were 0.1 m copper sulfate solution and 0.1 m iron sulfate solution. First, we dissolve different amounts of chitin into distilled water. Then add 1 gram of acetic acid. Pour it into the mold and wait until a film is formed, then cut it up for use. We can see the different formulations of chitin film in these figures. Second, sodium alginate was dissolved in distilled water. Then added drop by drop to 5% calcium chloride solution. The formed calcium alginate bits were filtered out and washed with distilled water for use. Then, prepare 250 ml each of 0.1 m copper sulfate solution and 0.1 m iron sulfate solution. As shown in the figure, we divided each solution into 4 packs of 15 ml. After adding each absorbent, the conductivity of the solution was measured using a conductivity meter after 10 minutes, 20 minutes, 30 minutes, and 24 hours of resting. The conductivity of the solution was compared with the initial conductivity of the solution. Experiment 2 was conducted to study the absorption of copper ions by various types of calcium alginate spheres. We first prepared calcium alginate spheres by the above method. In addition, another 2 absorbents were prepared by adding chitin and activated carbon respectively during the preparation process. In this experiment, we stored the absorbent in the refrigerator for 10 days before testing. Similarly, we prepared 0.1 m copper sulfate solution and added 3 calcium alginate spheres, and the conductivity was then measured at a specific time. Based on the experiments 1 and 2, we also investigated the absorption of copper ions by 4 membranes and the stability of the experiment. These include chitin membrane, alginate chitin membrane, eggshell membrane chitin membrane, and activated carbon chitin membrane. The absorbance of each solution is measured and compared with the untreated sample, and the concentration of heavy metal ions in the solution is analyzed to see if it has decreased. After making the 4 types of membranes, we prepared 2 packs of 0.1 m copper sulfate solution 250 ml. 16 portions of 30 ml were divided into 4 groups, and the corresponding testing time of each group was 10 minutes, 20 minutes, 30 minutes, and 24 hours respectively. In each group, 1.5 grams of chitin membrane, 1.5 gram of alginate chitin membrane, 1.5 gram of eggshell membrane chitin membrane, and 1.5 gram of activated carbon chitin membrane is added to 4 cups of solution respectively. When the corresponding time was reached, we took out 20 milliliters of each cup of solution. Add 0.3 grams of EDTA, stir and wait until precipitate appears at the bottom. Filter the insoluble material and transfer the solution to the colorimeter sample well. The absorbance was measured at each of the above time points using a colorimeter.
Now, for the data analysis, this graph indicates the conductivity data of experiment 1 after adding different absorbents to 2 solutions. For the 2 solutions, after adding each absorbent for 24 hours, the overall conductivity decreased. The decrease in conductivity was the largest for the chitin membrane A sample. This graph is a result of experiment 2. All 3 types of calcium alginate beads effectively absorb heavy metal ions from the solution. Among them, the calcium alginate chitin beads show the greatest decrease in conductivity. After experiment 3, we compiled a graph to analyze the absorbance data. From the above graph, it can be seen that for the copper sulfate solution, after the addition of the 4 membrane absorbents, the absorbance of each group of samples decreased significantly after 24 hours. The absorbents were effectively in absorbing heavy metal ions from the solution, and the longer the time, the more obvious the effect was. Among them, the decreased trend is most obvious for the chitin membrane samples and the activate carbon chitin membrane samples. Finally, we summarize the experimental data in the following graphs, which reflect the percentage reduction of ion concentration in each solution after 24 hours absorbance addition. According to the bar graph, the ion concentration of the solution decreased significantly after 24 hours of resting, and chitin membrane A was the most effective absorbance in this experiment, with an average reduction of 27.24% in the heavy metal ion content of the sample after 24 hours. In addition, the longer the alginate beads were left, the better the absorption capacity was. The alginate beads with the addition of chitin were more effective, with an average reduction of 22.61% of heavy metal ions in the samples after 24 hours. In addition, the content of heavy metal ions in the samples were reduced by 40.09%. After 24 hours, when activate carbon was added to the fin during the chitin membrane production process. Combining the data from experiment 1 and 2, the chitin membrane was the most effective absorbent in this experiment, considering the stability and continuity. Thus, it can be proved that these absorbents are effective in removing heavy metal ions from their solution, and the longer the time, the better the effect.
Future prospect. Last but not least, let us summarize the future outlook of our research in the future. We hope to simulate the real environment when we conduct our experiments. Moreover, we would like to simplify the procedure of measuring heavy metals so that we can measure the concentration of heavy metals at any time. Finally, we hope to integrate our research with the United Nations' 6th Sustainable Development Goal. If our research program can be used in the future, the needy will have access to clean water in the most cost-effective way. In this way, people around the world will benefit from our research.